Okay, so now let's talk about how to attract particles to the curve. To do this, I will create, let's say, a grid to emit my particles from, like this, and let's make it smaller, something like that. And let's connect it to first input of PopNet. Um, Inside of PopNet, I need to create a source, use my first context input, um, and the emission type I need to switch from points ordered to surface random. So this will create particles randomly on surface. Alright, and now let's apply a bit of force. Let's say this goes up, like so. And now I need to create a curve. I will create it in context, so the curve will stay here. Curve, and let's my front, right. Okay, let's say from here. Oops. So let's say that's my curve. And let's move this a bit just to make it nicer. Yeah, something like this. And one more thing is uh, how to change the handle. So this will stay like vertical here. I need to right mouse button click and in align handle I need to switch from object to the world, like this. So this will bring my handle to local world space. Alright, so let's say this is a curve. And let's connect it to second input of PopNet. And this disappears, which is fine. Let's go inside, and here I need to create an follow node. Not follow, excuse me, attractor, and let's select the second context geometry as input, and let's play animation. Nothing happens, which is fine. I need to create a force along the edge. To do this, I need to create the points up, right? And in particles, in force, I have an keep edge force. I need to add a bit. So let's play. Alright, you see that behavior is changed. But now particles are really uncontrollable. To fix this, I have to create a drag. This is really helps to calm down the particles and give me some control. The problem here is that sometimes it takes a while until we find the right numbers for the particles for its behavior. All right. Uh, Next, I need to create a radius. Add radius for the particles for the force. Well, let's say leave it as 5 for now. But the problem is that my curve doesn't have normals. I need to add normals. To do this, I need to switch to standard tab, and instead of keep normal, I need to add normal. Okay, probably it's a bit hard to see, but the normals are not pointed in the right position. That's alright. Let's delete this and say 5 here. So yeah, now I can see my normals on the curve, and if I will move it like this, I can't find the right position for them because my normals should follow the curve, like so. To do this, I need to write an expression. And to open this window, I have to press Alt E. And here I will type point. This asked me for surface node, and I need to use my previous node, which is edit1. So to do this, I type that. Well, that's just expressions, and probably I will cover it in next lectures. But for now, I will just type and describe it as well as I can. All right. Plus op input. Like this. And in op input, I need to choose a node which I want to use as a part of the name. All right, and type 0 here, like this. Then I need to write a parameter which I want to use. So $pt for points plus 1 then p for position and 0. And I need to do like this $tx. So this will take the point with point number from current point. This will take next point, take position of this, and minus the current position. Okay, apply. Ty. Okay, this should be ty here, and tz here. All right, and I have an error. Well, let's resample curve first. Resample. So now I have now I should have more spans. All right, and now let's take this And this doesn't work, so let me check what's wrong here. Alright, so the mistake was in here. So this should be 0 for x, 1 for y, and 2 for z. That's because the attribute, the normal, it's a vector. So 0 is for x, 1 for y, and 2 for z. And I had the typo, op input. I had op input, which is my fault. Right, let's talk a bit more about what's going on here. So the op input function, not function, but expression, it takes the information from node. And here I'm defining which node is it. So by point, I'm telling that this is a node which connected to 0. And 0 is this. If I would connect it like this and disconnect it here, I need to set 1. Alright. Next point is taking the parameter from a specified point. And here I'm telling to the function, to the expression, from which node I want to take this point. Then I'm saying which point number is it, then attribute, and if something goes wrong, this will be 0. Alright. So now I have my normals pointed in the right direction. You see it goes here. Okay, let's play the animation. And now particles start to behave a bit different somehow. I will decrease the number of rows and make the grid smaller like this. Right, so play again. Okay. In a director node, I have a scale. This is like a scale for attraction force. Right? Now let's increase drag. Too much. Okay. Let's play with. Oh, I forgot to add normal force. And this can be really tricky to make them follow. But this is one of the easiest way to do how to do this. There is more advanced ways, but they're kind of really hard. Okay, so let's decrease the force. Make the radius h. Make the forces smaller. Alright. And alright, so as I told you, it's a bit tricky to find the right numbers. but I did this. I haven't changed anything here except numbers in forces, and I have the same source, attractor, and drag. But again, I just was playing with numbers to make it look good. And I turned the grid because initially it was like ZX. Well, it works with ZX too, but yeah, right. I just turn it like this. Alright, so now particles are following, and the main things I need to have is correctly set it up normals and at least two forces, edge force and radius. As you can see, my radius is very small because once I add a bit more radius, very tiny numbers, particles are starting to move. Okay, let's add a bit more. Faster. And now my edge force is kind of small. If I add a bit more, you see the particles are moving really fast. Really fast, and they're not following it. While if I set my radius smaller, like this, they start following it. So something like this. And the speed should be, the radius here, just for these conditions, should be kind of small. For bigger simulation, the numbers will be specific, so there is no reason to remember this. All right, and here on top, there is an interesting effect. The particles, they like accelerated along the curve because there is a force, but once they leave the curve, they just keep flying with inertian speed, inertian force, and they're slowing down. And it looks like they're pretty even because there is no noise. And yeah, but at least they follow. Yes. All right. And now let's talk about a bit advanced stuff, but I want to show you how to convert particles into uh, debris and explosion. So I have a scene which I set up previously. Right. Okay, and that's how it looks for now. And let's see how this works. Now I need to decrease the quality just for speed, like this. And here is an explosion. And you can see that two particles are flying away. For some reason my viewport is not working properly today, but that's how it looks on rendering. So I will not cover the rendering stuff now, but only how I set it up. Okay, so let's rewind. And first I created the sphere. just a sphere, nothing more. Then I transform it to, yeah, okay, that's not really correct. The first step is to create a sphere, and then I apply a standard fire effect, just one of those, explosion, let's say. And this has created a network for me, like this, and out it up. This looks pretty familiar, except one node here, which is manually added to here. All right, so once you create this, so let's say this was a default network, that one. Then I start to create my particle system. So I took a sphere, like this, and let's disconnect this for a moment. I will turn off the simulation here. So, all right. So I have a sphere which I brought to PopNet, emitting source here, and I have just 10 particles emitted by first frame. Then I apply some force, just to make it not so boring. And where's my particles? All right. This should fly away. Yeah, right. Then I apply force. Maybe something get broken. Force contacts. That's really strange. Okay, I will reopen the sim. Alright, so I just reload my sim and looks like it's working now. So I have my popnet, the source, which is emitting particles, force, and the drag. Yeah. Alright, so this one is pretty familiar, and in the WOP pop, I'm doing kind of simple stuff. I took the age of the particle and then complemented, so 1 minus x. So the elder my particles are become, the smaller value I got here. Then I multiply it, well, just leave it for a moment, and then I feed it to color, so I can see the particles getting elder by changing color. So you see they become darker and darker and like fading away. All right. Then I did the same for velocity. So the elder they become, the slower they are. So let's say life expectancy 100, so I can see my particles. And I will disconnect the color for a moment just to see how they slowing down. And yeah, that's the problem. They're flying away. But I fix it with life expectancy. So All right, let's bring color back and set life expectancy to 1 and a bit of variance. Yeah, like this, for example. All right, so that was a popnet. And this one is just multiplier for velocity, so I can control it for here, because if I set it to 1, so no multiplication, the velocity is pretty small. So I decide to do it like this. So my particles can fly away really far. All right. That's possible to simulate the gravity force here. Say 1. But it's necessary to do some stuff in WAP. So currently I will have it like this. Next, I'm doing a trail thing, which is really useful node. So, all right, I will delete the color and set life expectancy to 100, so they will stay in place. And probably, yeah, I will disconnect velocity too. All right. So now the particles. Oh, sure. Age to velocity, something like this. So the elder they become, the faster they move. Right, that's okay for now. And trail. This node can create a trail, or this can compute the velocity. And currently I have it connect as polygons. What it's doing for me is creating a curve. So you see, I have points, and 4 of them are, because it stands trail length here, it creates a curve which will follow the movement of the particle. So let's say I want to have a longer curve, like 10, for example, and cache size for 10. Reset cache and play. So now my trails are way longer. All right. I can switch to preserve original. So now my particles are created, but no connection here. Well, that's not a big deal. I can leave it as just preserve original, because I actually don't need the curve. Connect as mesh. So this will create such mesh and just connect all the uh, particles. But it's possible to change it to different types of connection. So triangles, quads, alternative triangles. Yeah. And to get some effect from changing it here, I have to replay the animation. So triangles. Rows and columns. Oh, so you see it's a bit different. So I turn off, and let's preserve for original. So my particles. Next thing is just copy the spheres to each particle like this. So I have this sphere, I just transform it because initial sphere is kind of huge. Like this, I copy it to the particles. Alright, and next convert it to volume. Like this. I can apply more noise to here. Let's say something like this. And I can play with these parameters just to find something that looks interesting. Let's say pulse duration, different turbulent modes. Okay, this is noise, so let's say I want to set a higher noise for this because like small debris they should be noisy. Alright, I guess it's possible to use a volume pop here, for example, and apply a turbulent noise as an example. So take a point position, attach it to position, and multiply it to current position. Or I can add density to here and do something like this. Yeah, well, density must be here. And the position should go to looks like I'm doing this just in the wrong place. So let's delete this, bring density back to here. Alright, I need to apply a pop before, and also I need to convert my spheres to volume, like that. No, not ISO, but ISO offset. Yeah, like this. Alright, so delete volume pop. Density. For some reason it stands density here, but it should be a different one. Yeah, alright, let's try to bring it here, for example. Oh, oh. Strange. Alright, so but that's definitely possible to add some noise. Alright, so let's play it up to here. And yeah, I have lots of spheres converted to volume. And this volume has fuel and temperature. So I can add some velocity volumes and, for example, apply a bit of velocity, curl noise. Yeah. So let's see how it looks. Yeah, I will rewind up to here. Well, this looks like there is not much velocity. There is no velocity. Yeah, alright, let's turn this off. Okay, there is a velocity. something like this. So by controlling swirl size, I can add it, make it really convoluted. Alright, and this goes as an output for DOP network. While this one is standard, I'll disconnect it here. Alright, so now let's go back to AutoDOP network and activate all of the nodes. And here I created a new node. It's the same like original, but instead of this volume path, I'm using the path for particles. And the parameters here is just default from preset because it wasn't the goal to make something really nice looking. The goal was to make particles work as debris, which is flying away and burning. Alright, and where is my particles? Yeah, the quality. I forgot to decrease it. Alright, so particles should be somewhere around here. Oh, sure, I changed the behavior in VOP, so velocity and color, or yeah, I'll take color from here. Alright, and that was done. So yeah, particles are flying away, and since I create a longer trail, this creates more smoke. And let's turn off visualization for the velocity, and let's render. So yeah, the particles are flying away and create like debris looking stuff. I can change values here, and this will affect the behavior. So yeah, my viewport don't want to work today properly, or maybe I did something wrong with particles, so which is most likely. But you get the idea how to make particles fly away and burn. I'm pretty sure there is better ways to do this. And in next lecture, when I will talk about new particle system, I will try to investigate a better way which will give more control, but I hope I can do this. If not, then sorry. Alright, thanks for watching and see you next time.